Up next, we're going to do some probability, but we're going to leave all of the big computational stuff for your probability and statistics teacher, and we're going to keep it fairly simple in Algebra 2 here. So probability is a really simple idea. It's going to be the number of positive outcomes over the total number of outcomes. So you can see I've got it written here as P is equal to positive over total. Then this is what we call experimental probability. Then we've also got theoretical probability, which actually uses a formula, P of A equals M over N. There's no difference between the two though. The M is still the total positive, and the N is still the total number of possibilities. We're also going to take a look at odds real quick. Odds is just the positive number of outcomes over the negative number of outcomes. So it's the total number of outcomes. The negative is the same thing as saying the total minus the positive. We'll talk about that in just a second. So let's look at problem number 1 in the book. It says 15 of 60 vehicles in the teacher's parking lot are trucks. So what is the probability that if you pick one vehicle at random, that is going to be a truck? So the 15 represents the number of trucks. So we want to know if you were to pick a truck, or if you were to pick a car at random or a vehicle at random, would it be a truck? So the trucks represent the positive total possibilities. So we're going to say 15, and then what is the total number of possibilities? Well, there are 60 vehicles in the teacher's parking lot, so that's our total. So 15 over 60 is going to give us 1 over 4, which means that there's a 25% chance that if you chose a vehicle at random, that it would be a pickup truck. Now, what if we were doing odds on this? Odds is going to be a little bit different. So odds, we would say that, again, that the positive is going to be 15, but this time we want the negative number of outcomes, not the total number of outcomes. So we would say 60 minus 15, well, that's 45 negative outcomes. So we would change this to 1 over 3, and so that there's a 1 in 3 chance that you would choose, or there's one chance that you would choose a truck, and 3 chances that you would end up choosing a car or some other type of vehicle there. Now in problem 3a, the question is, if you have one die, what is the probability that you will roll a 5 on the first roll? So if we think about this, how many 5s are there on one die? Well, there's one spot for 5, and there are 6 spots total. So that means that you've got 1 in 6, which is going to be approximately a 16% chance of rolling a 5 with one roll. If we were to look at this again in terms of odds, then it would be 1 over 6 minus 1 would give you 5, and so it would be 1 in 5 with that. Now, if we're looking at problem number 3b, it's going to complicate it a little bit by adding a second die. So we've got 2 dice, and we want to know what are the chances of rolling the sum of 5 with 2 dice. So the first thing we need to know is that there are 36 different combinations that you can achieve with dice. So that's going to be our total. 36 is going to be our total. Now, the positive number of outcomes, you can roll a 1 and a 4, you can roll a 2 and a 3, you can roll a 3 and a 2, or you can roll a 4 and a 1. And so there's 4 different outcomes that you can have with those 2 die. And so what this means is that we've got a 1 in 9 chance, which is going to be approximately 11%. Now let me come back here over to the terminology that I've been using for odds. Odds is not 1 in 5, or it's going to be 1, 2, 3, and 1 to 5. So we use in when we're dealing with probability, and we use 2 when we're dealing with odds. Now if we were to look at the odds on this, we've got 4 possibilities, 4 positives, and then 36 minus 4 gives us 32. So this would be 1 to 8. 1 chance to 8 chances of negative. Now in problem number 5, we're going to apply probability to geometry, which you would have done last year, we're just going to revisit it. So in this case, what we're looking for is if you've got a batter that has a strike zone that is 22 inches high and the plate is 17 inches wide, what is the probability that the pitcher is going to throw a strike in high and tight to that batter? And so what we need to do is we need to figure out what are the total number of outcomes versus what are the total number of positive outcomes. Well, the positive is going to be pretty easy. It's going to be 6 times 4, which gives us 24 positive outcomes. Now, to find the total number of outcomes, we need to do 22 times 17. So we're going to get 14, 15, 0, 2, 2, 4, 7, 3. There are 374 total outcomes. So we're going to get 24 over 374. So positive over total. And we know that 74 cannot be divided by 4, so we can divide both of these by 2. We're going to get 12 over, and then let's see, 37, 18, and 187 should be our number on the bottom there. 180 times 2 is 360, times 7 is 14, so yeah, 374. So it's a 12 in 187 chance of throwing a strike high and tight, at least by the definition given to us by the book. Now again, if we were to look at what are the odds of this, then we would take 24 over, and then 374 minus 24 gives us 350. And so this would give us odds 12 to 175. And that's how we're going to do probability and odds.